All right, so we're here. Let me put my mug up here in the corner. Yeah, it's not the sloppy office. It's my wife's nice basement that she that she keeps for me. Anyway, wearing my Mighty Ruth thing, which we're on Christmas break for the most part. Just wanted to show. We're going to be doing the work energy theorem here, and it's not that difficult. The beautiful thing about taking a course like this is you do not have to. Um, we're not going to do any derivations and things like that, and usually derivations don't mean anything until you get higher up in physics anyway, and then you start saying, oh, now I make the connections and stuff. At our level, it's just interesting just to see how the changes of energy work. We're going to talk about two basic changes of energy, or types of mechanical energy. We've already seen force times distance is equal to work, which gives us joules of units of work of energy, and a change in kinetic energy. Kinetic, we just did kinematics. This is a unit on kinematics, which means things are changing. You know, the position, the motion. Well, basically, we're looking at the speed here. And the nice thing about energy is that it is not a vector. We don't have to worry about the direction. I'm trying to keep worrying about the direction at a minimum for this class anyway. Um, so, but the for this type of course, because that's what really trips people up. Now, when we get to momentum, you're going to have to be careful with the direction. But anyway, so when we're doing these small little um, uh, when we're doing these energy problems here, where we're just looking at two mechanical energies, kinetic energy, which means it's moving, flying, and gravitational potential energy, the change in height of something. As it moves up, it gains potential energy. We drop it, boom, it loses its potential energy and gains kinetic energy. Or if something is moved so that its kinetic energy changes, either positively, that means positive work was done. If the kinetic energy changes negatively, in other words, if it slows down, that means negative work was done. That's the big idea behind the whole thing. So I'm glad so now let's actually look at the equations for it, and in a short video, and in another video where we'll practice some problems. Okay? All right, so it's not going to be too bad.